and welcome to the channel Let's Learn Electronics. In our last lectures, we had thoroughly covered the topic of resistance levels in a diode. We discussed what is DC resistance, dynamic or AC resistance, and in the end, average AC resistance. While covering the topic of average AC resistance, I had mentioned that this topic is very useful while analyzing or making diodes equivalent circuit. Now, what is a diode's equivalent circuit? It is a combination of elements properly chosen to best represent the actual terminal characteristics of a device, system, or such in a particular operating region. In simple words, if we have a diode, it has a characteristics curve. We get the output, we keep on plotting the output, and in the end we get a curve, characteristics curve, indicating or describing the behavior of the device. Sometimes it's tough to implement or analyze the circuit having a component like diode. The traditional circuit analysis approach cannot be applied on those circuits. So under such circumstances, we sometimes have to replace the component diode with an equivalent circuit components. We have to put some other electrical components in the device, and we have to ensure that the ultimate characteristics curve, the ultimate behavior of the output remains more or less same. The ultimate curve which is indicating that this and for this input we are getting this output. The result, the output is almost same. So those components which replace the diode circuit, that modified circuit is called a diode's equivalent circuit. Let's understand it further. There are three types of equivalent circuits: piecewise linear equivalent circuit. Another modification is done in the second one, simplified equivalent circuit, or it is also known as constant voltage drop circuit. The third one is ideal equivalent circuit. Let's start with the first category. In this piecewise linear equivalent circuit, what we do, we know that every component has some resistance. So here in this circuit, we are introducing a resistor over here in place of a diode, indicating that this is the resistance of the component. And what kind of resistance it is? It is that average AC resistance which we calculated or we discussed in our previous lecture. So if you don't know what is an average AC resistance, please go through our last video. I will also add the link in the description box so that you can simply click and watch the video. This is the average AC resistance of a diode. We have introduced it here. This ideal diode is just indicating that the current is unidirectional here and the current will flow in one direction only. Once this the applied input will be reverse biased, then the diode will behave like an open circuit. This technique approximates the characteristics of the device by straight line segments. That means that the actual characteristics is slightly different. This curve has this plot has this curve, especially in the knee region, whereas the graph for the piecewise linear equivalent circuit is slightly different. It has straight line segments like this. It's coming like this in the blue line. But more or less it is approximately as good as the actual one. So we consider that this is the equivalent response this circuit is equivalent, almost same as the original diode circuit. Now this sloping section, it is indicating the average AC resistance RAV over here. This RAV is indicated over here, and this ideal diode, it is just representing the unidirectional property of the circuit. It is just telling us that if the input is applied and it is forward biased, the diode is forward biased, the current will go in this direction only, and once the polarity is inversed and the circuit is reversed biased, the diode will behave like an open circuit. I have just mentioned it. And this battery Vt here, it is just indicating that the barrier potential of the diode has to be overcome. The input voltage has to be greater than this barrier potential or the knee voltage in order to make the diode conduct. In order to switch on the diode, the input voltage has to cross this limit of 0.7 volts. Let me just give you a quick overview what is the relation between resistance and slope. If a curve has more resistance, for example, if a diode or a circuit has higher resistance, then higher resistance means it will be very difficult for the component to conduct. So this behavior will have a curve like this. It's a very slow progress in the conduction curve. In this curve, VI characteristics curve, this is VD, this is ID, and the resistance is very high. For example, RAV is high, it has a good value, it is high. If it is high, then as you can see, the slope of over here is very low. The value of the slope is less. Graphically I am just explaining it. And now, for example, if the resistance is very less, that means the device is conducting fast, and we see a sharp increment in the conduction, in the current. So right now over here RAV is less, and then the slope is forgive my poor handwriting, just remember that it is inversely proportional. This is what I am trying to emphasize, that the slope and the value of RAV is inversely proportional. Must remember this point. It is often asked in many MCQs in competitive exams, what is the relation between slope and the resistance. They are inversely proportional, so if the resistance is less, the slope is high, and vice versa. For example, over here we have introduced on 0.8 volt there is a sharp increment in the current, and we are having 10 milliampere of current. So we know that the average AC resistance is the difference of maximum to minimum voltage. RAV is equal to 0.8 minus, the diode starts conducting only after crossing the 0.7 volts, so the minimum limit will be 0.7 volt. Just subtract 0.8 minus 0.7 volts. Keep a pencil in your hand, and 0.8 volt, the current is 10 milliampere, and on 0.7 volt the current is 0 because the diode has not started to conduct. So what is the value of average AC resistance? It comes as 10 ohm. Can you see the answer? Calculate it by yourself, you will understand it better. Now let's move towards the simplified equivalent circuit. In this kind of circuit, we will be ignoring the value of RAV. We will consider that the average AC resistance has a very small value and it can be ignored, it can be neglected. So after neglecting it, the circuit will be modified as this. There is no value of RAV, and once the resistance is 0, look at the change in the graph. the plot will be like this. RAV is 0, so the slope is infinite and we have got a perpendicular line like this. The battery is still here because we are still considering that in order to make the diode conduct, in order to forward bias the diode, the input voltage has to be greater than this knee value, this 0.7 voltage value. So this VT is still in consideration, and this is the simplified equivalent circuit. We also move ahead, and this is the further modification. This is the final equivalent circuit we have. This is called ideal equivalent circuit. Here we have neglected the value of VT. We are neglecting that. Okay, fine, input voltage is high enough that this knee voltage is negligible, so just remove the battery from the circuit, and the ideal condition is like this. We have an ideal diode which behaves like a switch. So if the input voltage is forward biasing the diode, it starts conducting and behaves like a closed switch. The moment the input voltage is reversed biased, the polarities are inversed, then this ideal diode behaves like an open circuit. And under this consideration, the graph changes like this. We have an ideal plot where the current just starts flowing the moment the switch is on, and it stops flowing the moment the switch is off. Summarizing the lecture, here we have three kinds of equivalent circuits: piecewise, simplified and ideal one. In piecewise, we have a resistance RAB indicating that the component diode has some resistance. So when it has some resistance, then we just take the average value, the average resistance, and we put the equivalent resistor over here in the circuit. And we also consider now just closely observe that the polarity of the battery is inversed. It is indicating, I'm emphasizing this point, this battery is just indicating that the input voltage has to cross this value in order to push the diode in the conduction mode. It is not a physical battery connected in this circuit. It is indicating that the input voltage has to overcome the value now. In the simplified equivalent circuit, we have ignored the average resistance value, approximating it as there is no resistance in the circuit, and we only have VT in the knee voltage in consideration. And in the ideal equivalent circuit, we have neglected everything. All we know is an ideal diode. I hope I have helped you in understanding this topic. If you have any confusion, please drop your queries or your doubts in the comment section, and connect with us on our email ID if you want any assistance or help in preparing your assignments or in any kind of academic writing work. I am also mentioning our email ID in the description box. Please feel free to connect with us, and don't forget to like the video, share it among your peer group, and subscribe to the channel to stay connected with us. Thank you for watching the video. Bye bye.